All right, today is a not continuation. It's actually an easier version of what we were doing yesterday. No. Diet Coke with lime. Yeah. Wait. Okay. All right. Jonathan, Juan, Brianna. Next time I'm moving you. Okay. Similar polygons. Similar polygons have this symbol. They have the same shape, but not necessarily the same size. Not necessarily the same size. If you guys remember Cool Math Dude, all of these are all similar. This is bigger, this is smaller, but they're all the same shape, all the same picture, just blown up or shrunken down. Okay, that's a symbol for similar. I want someone to read to me this sentence right here. Right here. Who wants to read that for me? All right, who's me? All right, what is it?
Two polygons are similar if and only if their corresponding angles are congruent and corresponding sides are proportional.
Perfect. Key out of this is they're similar if the corresponding angles are congruent and the corresponding sides are proportional. Sides are proportional, angles are congruent. Let's see how many people were paying attention. Fill in these sentence stems. If the two polygons are similar, then the corresponding angles must be blank. Raise your hand if you think it's congruent. Raise your hand if you think it's proportional. If you don't know, I want you to read that sentence that was just read.
If two polygons are similar, the corresponding angles must be
Congruent. If two polygons are similar, then the corresponding sides must be proportional. All right. While writing similarity statements, it is super important that you write it in the right order. This is why. If this is not a triangle. If polygon NPQR is similar to UVST, list all the pairs of congruent angles and write a proportion that relates to the corresponding sides. Here's why order matters. N, we're looking for what is corresponding with N. Well, N is first in line, so U is also first in line, so those two are corresponding, so they're in the right order. P is second in line, so what is second in line in this statement? V. Q is third in line. What is third in line in this one? S. And then R is last in line. What's last in line over here? T. I would also recommend filling in the diagram. N is corresponding with U. P corresponds with V. Q corresponds with S. And R corresponds with T. Okay? I think this is more useful than this. That's just me, though. Okay. Pn. What does Pn correspond to? Well, Pn is this side. And Pn goes from 1 tick to 2 ticks, right? 1 tick to 2 tick is UV. But there's actually a much easier way of doing it. It's not much easier, it's just easier, though. We have Pn. P is first in line, sorry, N is first in line, P is second in line, U is first in line, V is second in line. PQ, second, third, second, third. So it's going to be VS. QR. QR is third and fourth, so that's going to be S and T. This is the tricky one. Fourth in line, first in line. Fourth in line, first in line. So it's TU. It is not UT. We're Aggies now, TU. Man, you guys don't get that joke at all. Aggies call UT TU. Okay. Man, that joke would have killed in Aggie land. All right. All right. Identify the pairs of congruent angles and find the ratio of corresponding sides. We'll start with identifying the angles. Hey, Jonathan, why don't you move up here? Okay. B corresponds with what? G. How do you guys know that? Because they're both right angles. C corresponds with what? H. How do you know? Same measure. Both are 59. Finally, A corresponds with what? J. Why does it correspond? It's really the only one left, right? The real reason is called the third angle theory, but it's really good. Well, I don't know what you can think of it. A shortcut would have been just saying, oh, it's the only one left. Okay. So triangle ABC is similar to triangle, well, what is A equal to? J. What is B equal to? G. And what is C equal to? H. Triangle J, G, H. Okay, AB, now we're doing the sides now. AB, A is first in line, B is second in line, so it's going to be J and G. BC, second line, third in line, second line, third in line, GH. AC, first in line, third in line, first in line, third in line. Now we need to figure out what the actual scale factor is. Figure out the scale factor, we're going to divide the corresponding sides. We have AB, which is 10. 10 divided by JG, which is 5. That's equal to a scale factor of 2, or 2 over 1. BC is 6. GH is 3. That's 2. AC is 11.6. JH is 5.8. Remember what I said yesterday? Well, some of you remember what I said. I don't like decimals I don't like decimals inside of fractions. I actually don't multiply by 10, you multiply by 1, but a very special one, right? You multiply it by 10 over 10, which is the same thing as 1. 11.6 times 10 is 116. 5.8 times 10 is 58. Can those two be divisible by each other? Yeah, you divide those and you get 2. So do these all have the same scale factor? So are these two similar? Sure are. Ratio of corresponding sides is going to be a 2-to-1 ratio. What does that mean? That means this triangle is how many times larger than this triangle? Or this triangle is how much times bigger than this one? I know that's worded weird, right? 0.5, right? You'd multiply it by 1/2. Right? Do you guys think it's a coincidence? Do you guys think it's a coincidence going from this way to this way, it's 2/1, and going from this way to this way, it's 1/2? No, it's not a coincidence. You take the inverse depending on which direction you're going. If you're going from this is twice as large, this is 1/2 as large. Okie dokie? Oh, I want to go to your worksheet from yesterday. This gets glued into your ISN. I'm not doing that. I know. Why? Because I've been slacking. We're resetting it next semester. So we're gonna pretend like the next page is page 1. You can buy a new one. Yeah, but we're gonna restart it on. Okay. So let's look on. Well, I'm working on number 12 right now. All right, I'm working on number 12 right now. Jonathan. Or not Jonathan. Oh, I forgot your name. Joshua. Daniel. 12. Okay, I am going to do the work for 12 here. You do not put the work for 12 here. You put it down here. Okay? We're doing both of these, but I like this. This is more room than down here. Do we all understand that? Okay. So swimming pools. The Minette, I think, family and the neighboring Gaudet family both have in-ground swimming pools. The Minette family's swimming pool is PQRS. So this is the Minette one. The Gaudet swimming pool, and it measures 48 feet by 84 feet. The Gaudet family swimming pool is the other one, so this is G, measures 40 by 70. They're both rectangles. One property of a rectangle is that this side is the same as this side. This side is the same as this side. Those are the same. Those are the same. Yeah, and they're all right angles. 40 is the same as 40. 70 is the same as 70. It asks us, are these two pools similar? If so, write a similarity statement. First thing to know if something's similar, check the angles. What type of angle do we have here?
Right.
Yeah, those are stairs, but they're also right angle, right angle, right angle, right angle. All of those are the same. Right angle, right angle, right angle, right angle. They're all the same, right? So we have 4 pairs of congruent angles. So we're good on the angle front. Now we need to check the scale factor. Let's start with this, 48. What's the corresponding side for 48 over here? Is it going to be 40 or is it going to be 70? It's going to be 40. This is the short side of the pool. This is the short part of the pool. This pool should be twisted around if we wanted it to match, right? So we're going to have 48 over 40. 48 over 40 is going to be reduced. We're going to divide it by, 2. 2 is going to be 24 and 20. Can we divide that again?
Yes.
What can we? By 2 again, which is going to be 12. We could have done 4. 12 and 10. Divide this by 2 again, which is 6 and 5. You guys want to know what we could have originally divided it by? Well, we divided it by 2 here, 2 here, 2 here. 2 times 2 times 2 is 6. We could have divided both of these by 6. 48 divided by 6 is? Wait, I'm sorry. 8. 2 times 2 is 4. 4 times 2 is 8. We could have divided both of these by 8. Okay. Sorry. Okay. Yep, just checking it. All right. Now if we know this scale factor is 65, 6 over 5, what does this scale factor have to be? That's 48 divided by 40 again. 6 over 5 again. It's the same thing, right? We did this side, which is 48 divided by 40. This side, 48 divided by 40. It's the same thing. So we really don't need to do it again. Let's do the 84 one. 84 divided by what? 70. Let's reduce this. Both of these are divisible by what? 2, yeah, 2 works, whatever. So that's 42 over 35. What are both of those divisible by? 7, so we're going to get, oh wow, look at that, 6 and 5. We could have done this easier if we would have just decided to do 2 times 7. These are both divisible by 14. Okay. So do these have, and then this is the same thing, 84 divided by 70. So these all have the same scale factor. Same scale factor, same angles, these are similar. So we need to write a similarity statement. I'm going to start with P. The reason why I'm starting with P is because it has this landmark right here, right? P. Well, P is corresponding with which letter? X. I'm matching up the landmarks. And now we want to know a really easy way to get these fast. Start at P. Go clockwise. S. Go clockwise. R. Go clockwise. Q. Same thing. Start at the same place, and since we're going clockwise, we're going to go in the same order. X to Y. To Z. To W. And if you do that, they'll be in the same order. So you know it's not a 2. It's a squiggly mark. Because it looks like a 2. Watch. Right? No, I'm not trying to make it any more difficult. I'm telling you, asked me why I put the mark there, and that's why. No, we're not done. Okay, we are too noisy. We're too talkative. That doesn't mean continue talking. Are we ready to move on now? I have one more problem I want to do. Okay. We have a pentagon. We want to figure out the perimeter of both of these pentagons. We know they're similar to each other. Well, I notice we're missing some marks here, right? We know this is 10, this has 1 tick. What does this one have to be with 1 tick? And what does this one have to be? We can add perimeter, we add the sides together, right? So 10 plus 10 is 20. 20 plus 20 is 40 plus 10 is 50 plus 15 is 65. We know our perimeter is 65. Now let's figure out what this perimeter is. Okay, 21 plus, we don't know anything. We need to start figuring this out, right? Okay. So, we need to figure out our scale factor first. What's the only piece of information we know on this one? We know 21. What corresponds with 21? 2 marks? 2 marks, so it's 15. Common factor of 7 over 5. Common factor 7 over 5. Remember the order we went. We went from the large polygon to the small polygon. So we went from large to small. Now we can use this we need to figure out what each one of these are. Let's figure this one out. That way we can get 3 of them already. We know we have a scale factor of 7 over 5, so we're going to use a proportion to figure out the rest. We don't know what this is. We're going to call it x. Is the x going to go on the top or the bottom? Because we do large on top, so we're going to put the large on top. What is corresponding with this? It's really this one, but 10. Yeah, large to small. Okay. I'm going to cross multiply now. 7 times 10 is equal to 5 times x. Now, most people would just say, okay, easy. 7 times 10 is equal to 5x, right? 70 is equal to 5x, right? 70 is equal to 5x. 70 divided by 5 is what? 14? Let me show you an easier way. I would never do it that way. Let me show you what I would do. I would look at my problem. Oh, look, there's a 5 here. Is 7 divisible by 5? Is 10 divisible by 5? Oh, when's if I divide both sides by 5 right now? Cancels out. 10 divided by 5 is 2. 7 times 2 is equal to x. 14 is equal to x. So we know this is 14. Hey, look, we also got this one and this one. But we're still missing it. We don't know what it has to add up to. We need to use the same scale factor and figure out what this one is. 7 over 5 is equal to 7 over 5 is equal to, well, large goes on top, x over 20. Cross, multiply, 20 times 7 is equal to 5 times x. So once again, I would not multiply those first. I would first look, hey, that's divisible, right? Divide this by 5, divide this by 5. We get 4 times 7 is equal to x. 28 is equal to x. Do we know all our lengths now? Yes. Let's add these guys together. 14 plus 21 is 35. 35 plus 14 is 49. 49 plus 14 is 63. 63. 63 plus 28 is 1. Carry the 1. 8, 91. So we know our perimeter is 91. All right, let's see who's super smart. Spoilers, we just did a ton of extra work. This wasn't necessary, 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 all that wasn't necessary, that wasn't necessary, that wasn't there, that wasn't there. None of that was necessary. Yep. So we should have thought to ourselves, we know a scale factor, right? And we know this perimeter. And we're trying to find the other perimeter, and we know the scale factor. Instead of finding all that stuff, why don't we just plug in our perimeter first? Figure out a large perimeter. We could have said 7 over 5 is equal to, we're looking for the large perimeter, so x over 65. Cross multiply. Cross multiply, so we have 7 times 65 is equal to 5 times x. This is where that trick gets really important. I don't know what 7 times 65 is, and I don't want to find out. I'm going to divide both by 5. This kind of cancels out, so we get 7 times 13 is equal to x. 13 times 7. 3 times 7 is 21. 7 times 1 is 7. Plus 2. Wow. 91.
But I mean, if they would have asked us for like the other one.
Yeah, if we would have asked you for the other ones, you would have had to figure it out. But it didn't.
So you can only just figure out one.
Yep.
Then why did we do all that work?
Because now you remember that.
Oh.
Okay. 2 announcements. So, we are going to have our first project check on Thursday. Your project check is going to involve checking basic problems 1 through 5. I expect them all to be done.
Just that?
That's just a project check. Your homework. Your homework is worksheet 6.2, 2 through 10 evens. I know there isn't a number 4, so just skip it. It should be 6.2. Oh, 6.3. Okay. You have to look more carefully. Okay. Yellow 1, 2 through 10 evens. Green 1, 1 through 10. If you're here yesterday, you already did the evens for, or already did the odds for 1 through 10.